So we're going to pick up where we left off, and I have a couple videos here to ultimately kind of show you, hopefully, about the seasons. I was smiling about, we're covering seasons now in astronomy, and when I teach astronomy and meteorology in 16-week courses, we cover seasons in both astronomy and meteorology. But since you guys, we've already covered it in the astronomy section, we don't have to cover it in the meteorology section. So it's all good, okay? So in order to kind of make sense of Earth, we need to talk about longitude and latitude. You've probably run into these terms before. Latitude is, and they kind of make like little crosshairs so you can say where you're at on the Earth. Latitude are these like circles that go all the way around the Earth, starting at the equator. They go north and they go south. So lines of latitude separate us into the northern hemisphere and the southern hemisphere. The thing about latitude is it goes from equator is 0 degrees latitude, and then we have 90 degrees north latitude here, and then we have 90 degrees south latitude there. So that's kind of how that works. Longitude, I always kind of think long longitude. And so longitudinal lines actually go around this way. More to the point they go from pole to pole would be one line of longitude. And then, of course, it goes back around the other side. But here's the deal. There is a zero longitude, and the zero longitude is in Greenwich, England. So find what do they call it, the big pond or something like that? Let's see. So over here. Really? Yeah, there it is. Okay, I see 0 up here. So this actually is what we call the prime meridian. Okay, so this is 0 longitude, and then it goes east and west. So this would be east longitude, okay, and this would be west longitude, and then they meet around the back. So actually, if you go the 0 longitude, meet in the back, that's where actually both east and west meet. And that's 180 degrees east and 180 degrees west. And that is called the international date line. So that's pretty cool. Like if you stand on this side, you're one day. If you stand on the other side, you're another day. Okay, that's just kind of how the world has to handle the whole Earth spinning on its axis, and we have different time zones and everything. So speaking of Earth spinning on its axis, different time zones, the other day I put the sun in the middle here with my stool. Okay, this is the sun, and what worked pretty good is to go ahead and make kind of this plastic thing kind of the boundary, okay, of basically this would be, all of this part of the Earth is getting light, and all of this part of the Earth is in darkness, okay? So the Earth spins, it's all about counterclockwise, so the Earth spins counterclockwise. So here's North America, here's us, okay? So I kind of said the other day, does it look like maybe the sun is kind of about as high in the sky as it's going to be? So this might be noon for us, okay? And then we rotate. And here's our eastern coast. So actually the sun appears to set first in the east, okay? And then here on our western coast, California, they see the sun set last. So as you know, if you're like, do anything with television, they'll tell you what time the television show starts, but they'll tell you which time zone they're talking about. So we are in Central Time Zone. I'm not going to emphasize it too much this semester, but actually we are in what we call Daylight Savings Time right now. But we're in the Central Time Zone, this orange here. Okay, so I said the sun appears to rise and set earlier on the East Coast. So actually they are 1 hour ahead of us. Okay, this is Eastern Time, this is Central Time. This is Mountain Time. They are 1 hour behind us, and Pacific Time is 2 hours behind us. And Alaska Time, it looks like it is even farther. It looks like would be 2, 3, 4, and 5 hours ahead of us. So, or behind us, excuse me, behind us, to the west. So the thing about the Earth spinning, the Earth rotating on its axis, it basically covers 3 degrees of longitude for every hour. Sorry, 15 degrees of longitude for every hour. Okay, so if you take 15 degrees times 24 hours, that actually gives you a 360-degree circle. So that's kind of how that works. So if you want to jot down, I bet you have it in your notes, but if you ever want to know, actually pinpoint your location, you are here, and what is my latitude and what is my longitude, you can actually go to latlong.net and find that out. Keokuk, we are at 40 degrees north, so 40 degrees north of the equator, and we are at 91 degrees west of the prime meridian. Okay, so that's kind of our coordinate location. So we're going to talk a little more about seasons, and seasons, it's really helpful to get a fix on particular lines of latitude. So lines of latitude basically go north of the equator and south of the equator. So we have up here at 66.5 degrees north latitude, and actually on this globe, it's this little, they've got a little dotted line there, since it's so important. That actually is the Arctic Circle. And we actually have a counterpart in the southern hemisphere, little dot, dot, dot lines, the Antarctic Circle. Okay, and those are important when it comes to seasons. The other two lines, they are both 23.5 degrees. So we have 23.5 degrees north latitude, and that is what we call the Tropic of Cancer. And then 23.5 degrees south latitude, we call the Tropic of Capricorn. So those are all kind of important. And then, of course, kind of symmetrical in the middle there, we have 0 degrees latitude for the equator. These are kind of sweet lines on the Earth. Okay, so let's see. I've got a couple of videos to show you. Let's start with geographic seasons. It's about 5 minutes. I think they do a good job. Okay? So I thought the video did more than I could probably do with any of these. Okay, but I do want you to have a sense for the 2 solstices and the 2 equinoxes. The first video we watched, I don't know if you caught it too, but they showed the configuration kind of like I've been doing in here. We're going to talk again about the North Star, Polaris, and this actually is tilted kind of like this. This thing is tilted like this, okay? So actually, that's kind of what the first video was. So remember, that's key to a planet having seasons. That was the thing I was going to mention. We have, 7 other planets in our solar system, and only if the axis of rotation is tilted as it orbits the sun do you get seasons. Okay, so let's see, counterclockwise. Yeah, so it's like this. Okay, so we talked about this the other day. That basically it takes the Earth 1 year to do this once, and all the time it's spinning on its axis once a day. Okay, so generally know when the solstices occur. I kind of tell students, if you get the month down, if I ask it on the test, if you get the month down and say 21st to 23rd or whatever, I'm fine with that, because I can never remember if it's 21st, 22nd, or 23rd. Okay, so of course, in December, we have our beginning of winter. We call it beginning, but that's a whole nother story. December 21st or 22nd, that's the winter solstice. June 21st, 22nd, about 6 months later, is our summer solstice. Then we have those 2 equinoxes. And I've looked into it several times. I know I've had students say, can you, something about balancing an egg or something? And no, you cannot on the equinoxes. So anyway, broomstick. I guess it's a broomstick can stand upright. All right. So we're going to switch from our star, because the sun is a star, right, to kind of other stars a little bit. But just like we were talking up here, and I kind of made this kind of the transition between, I made this the transition in this case between daytime and nighttime. Okay, we see we see the sun appear to rise in our east and set in our west every day. Now, throughout the year, it'll kind of go. It won't be due east or due west, depending upon the time of year. But in general, it rises in the east and sets in the west. That's because the Earth is spinning. Okay, that's what makes that happen. And we call that actually diurnal motion. Okay? But I don't know if you've noticed this before, if you're kind of an outdoorsy sort of person that loves to gaze at stars. But in the same evening, for instance, if you find the Big Dipper, okay, a lot of you maybe know how to find the Big Dipper. In the same evening, if you find the Big Dipper, and actually it's kind of related to Polaris a little bit, you'll find it here, okay, and then maybe 5, 6, 7 hours later, you're going to find it over here. Okay, actually, did you see how I kind of swung my hand kind of, actually it's supposed to be counterclockwise around Polaris. So my hand is the Big Dipper. That set of stars has moved. And the reason that set of stars moves is the same reason the sun appears to rise in the east and set in the west. It's because the earth is spinning on its axis. Okay, so stars move throughout the course of the evening. And the thing about the Big Dipper is actually it's close enough to Polaris to basically be what we call a circumpolar set of stars, which means that actually they're always up. They never set below the horizon. If we take another star, we could look kind of where the sun is, and if we take another star, we actually, well, we couldn't see if the sun was there, but actually would see it rise due east and set due west, just kind of wherever that star is. So that's whether it's the sun. My mom hates the phrase, the sun rises in the east and sets in the west. She's like, Elizabeth, you teach science. You know the sun is not rising. You know, it's the earth rotating on its axis. I'm like, I know it appears to rise in the east and set in the west. It's the earth is spinning. Okay? And so that whole motion of the sun and motion of the stars throughout the course of a night, okay, we call that diurnal motion. So the next slide is and I've dabbled in what's called star trails. I'm dabbling in astrophotography. I better keep my daytime job, let me tell you. But astrophotography is just taking pictures of the stars. And so I told you that the Big Dipper will move. Okay, so here's the deal. If you want to basically kind of catch that movement, what you do is you have a camera that's kind of has to kind of have a mixed sensitivity to light. Actually, the way I made star trails was to take multiple pictures and then kind of stitch them together. But if you could take a camera and open up the shutter, basically you would see it kind of sweeping like that. That's what star trails are. Okay? And that is right here. So this was taken in the Northern Hemisphere, in Portugal. I know it's the Northern Hemisphere, because I'm not good with geography, obviously. But I know it's the Northern Hemisphere because in the Southern Hemisphere, you cannot see Polaris. Okay? Only the Northern Hemisphere, or kind of close to the Northern Hemisphere, can you see Polaris. It's only the Northern Hemisphere. So this is a star trail picture. Let me kind of switch lights here. So all they did basically was to take a camera, center it on Polaris, and open the shutter. And watch the stars create those trails. So we'll be talking a little bit about constellations. Of course, you see the Big Dipper. Where's my pen to write with? Okay, here's the Big Dipper, right? The cool thing about the Big Dipper, there's a lot of cool things about the Big Dipper, but actually the Big Dipper is what we call an asterism. Asterism. So it's not a full-fledged constellation. It's a piece of a constellation we call an asterism. Okay. The Big Dipper, actually, the asterism is in the Big Bear. Okay. Sometimes out at the observatory, I volunteer a lot out at the observatory for people just to kind of come for public viewing and stuff. Sometimes out at the observatory, people say, well, where's the Little Dipper? Well, the Little Dipper's harder to find. But if you found the Big Dipper, you have a fighting chance. So basically, these two stars, these I circled in green, we call those pointer stars. Pointer stars. Okay? And they're pointer stars because they point to Polaris. So do you see how they point to, oops, that's not a very good color. Kind of, a little bit off. But in general, they point to the star Polaris. They're pointer stars. Yeah. Cassiopeia is another, and that's a full-fledged constellation. That's not an asterism. Cassiopeia is actually the figure, the queen. She sits on a throne. Okay, there's a whole saga that goes along with these constellations. But Cassiopeia looks like a W or an M, depending upon. But it's like the Big Dipper, and it will swing around Polaris, and it's at a location that actually, it's always going to, at our latitude, we're always going to see it. It's what we call a circumpolar constellation. Okay, so now, this is a classic one to kind of make sure we all, it's a practical thing. We can all kind of do this. Whether you understand it or not, try to explain how it works this way. But if you can find Polaris, this is Polaris for us. If you can find Polaris, okay, this is our axis of rotation, okay. Basically, what you need to do is see what angle Polaris makes with the horizon. So in here, the horizon would be like the floor. So basically, you take the floor and you take the angle of Polaris. And whatever, or sorry, and you point the other line up to where Polaris is. That angle right there, kind of right to me, actually is our latitude. Now, what is a latitude? Remember, we just talked about it. Latitude is how far you are, in our case, north of the equator. I said we're about 40 degrees north latitude, okay? So the angle of Polaris actually gives you your latitude. Well, so, let's see. One good check, you know how we could check that? All right, so let's go ahead and take a road trip from 40 degrees latitude. Let's go up to visit Santa Claus, okay? Let's go up to the North Pole. Now, if we're up at the North Pole, you guys buy this? If I'm a little person standing on there, if I want to find Polaris, doesn't it seem like it's going to be right over my head? Polaris wouldn't be over there. It'd be like right up here at what we call my zenith. That's where Polaris is going to be. Like, okay, all right, there's Polaris because I'm at the North Pole and the north axis of rotation is pointing to Polaris. Okay, so Polaris is right overhead. What angle does that star make? Well, put one hand up at the star and put the other hand at the horizon. And I know it doesn't look like it. That's a 90-degree angle. Okay, 90 degrees angle. So what did I say this latitude was? 90 degrees. So we've just done kind of a quick check, but that is for sure how you do that. Okay, so here's a cool one. I'll go ahead and reveal the next one. I like this slide. It looks like a busy slide. If you look at this slide too much, you're like, oh my gosh. There's a sun in the middle, and you see the Earth orbiting the sun. That's fine. And then you see that series of suns on the outside, and it is kind of creepy. So here's the sun, and here's the Earth orbiting the sun in 1 year. But basically, those extra suns, all they are doing are actually showing you where the sun is in the background stars. First off, let me go back to sun and Earth. Okay. There's a concept we're going to talk about, I don't know if it's this week or next week, but it's called the celestial sphere. Here's the deal. So here's just us. We're little tiny. We're important, but we're a little tiny. We're Earth and the sun. Okay. If you go outside of our solar system, there's billions of stars in our galaxy, and then there are hundreds of thousands or billions of galaxies, millions of galaxies. So anyway, my point is there's stars out there. So here's the deal. Those stars out there, those are what we see in our nighttime sky, right? Makes sense? Okay, so I'm going to go ahead and I'm going to make this my boundary between daytime and nighttime. Does this make sense? We see these stars over here this time of the year. Okay? I'm going to go 6 months later, and now which stars do we see? Those stars. Okay? I can go 3 months. What stars do we see? These stars. Why? Well, those stars are out, okay, but in the daytime we can't see the stars because the sun's too bright. Okay? So as we orbit, okay, as we take 1 year to go around the sun, we get to see different constellations throughout the year. And that is so cool. People are kind of ramping up and getting excited, myself included. The constellation Orion is a beautiful constellation, and it is actually a fall constellation. So actually the Earth is going around the sun, so we can now see Orion. It's rising earlier and earlier. Okay, it's getting close. But that actually kind of leads to this figure. All it's saying is, for instance, if you are, let's see, I think it looks like the example they picked was, you know, I don't know, February. If you're here, okay, in February, okay, the stars that you're going to see actually are going to be, you know, Leo, Cancer, Virgo. These, by the way, your author picked these because these are, you might recognize, they are, if you're into astrology, they are astrology signs, zodiac signs, okay? So all it's saying that actually we see these stars here, okay, but the sun appears to pass through Aquarius. The sun is passing through in February. Now, can we see Aquarius? No. But that's kind of where the sun is passing through. And if I understand astrology, which I don't, but you are named after the constellation of the zodiac as the sun is passing through that time of year. But here's a catch. Oh, by the way, notice we talked about the ecliptic. We talked about the ecliptic last time we were here on Monday. What the ecliptic is that kind of sheet of paper that basically holds the Earth as the Earth goes around the sun. That's the plane of the ecliptic. Here's the deal. All of these special zodiac constellations lie on the plane of the ecliptic. Okay? The sun appears to move against the background stars on the ecliptic. So here's the problem. So if you go ahead and find your birthday, and just bear with me. Find your birthday and see if this seems right to you. How many people see it seems wrong? Oh, that's what I usually get. Mine too. The problem is there actually is a 13th constellation, Ophiuchus, and astronomers would say that the sun passes through Ophiuchus too, and it does. So basically what that does is kind of move everything else around. Can you still go with yours? Yes. Is Ophiuchus really there? Yes. Okay. So, yeah, it messes mine up too. I'm like, really? How could they do that? Okay, so the last topic I want to talk about is this one. And I'm going to kind of backstep on this whole thing. I said, and it will for our lifetime, I said basically as the Earth orbits the sun, its axis of rotation will always point to Polaris. That's what I said. Okay. But it's a cycle. It's a long cycle. And if you actually look at these dates here, 2000 CE, 14,000 CE, so that's what? A lot of years. 12,000 years. In 12,000 years, actually, what's going to happen is our Earth's axis will still be tilted. So you see here, 14,000 years from now, or 12,000 years from now, our Earth's axis is tilted, but it's going to be pointing another direction. So it's going to take about 12,000 years to basically make a half a circle. This coning action is kind of like a top. If you've taken a top and kind of let it rip, you'll see the top is straight up at first, and then you'll see the top, and it's spinning, really fast. And then you'll kind of see this top kind of start to do this before it starts to kind of get more and more and more and fall down. Now the Earth isn't going to do that, but basically kind of that coning action, while it's still rotating on its axis, is kind of what we call precession. So it takes a while, So our North Star is Polaris right now, and it was 26,000 years ago, and it will be again in 26,000 years. So that's kind of the time it takes to make one coning. Okay, but all the time the Earth's axis of rotation will be tilted kind of similarly. Another cool star, which when we talk kind of briefly about stars, we might end up talking about a star called Vega. Vega is in the constellation Lyra. It's a very small constellation. Lyra, kind of like a lyre. So I watch those. I think it might have been one of those alien shows or whatever. And so one of the things they talk about is historically the Incas and the Mayas. They were really into the stars. It's sometimes I wish all the power would go out and we'd all have to appreciate stars again. But one of the things that they noticed actually is for instance, the solstices we just talked about. You know, when is the longest and the shortest day of the year? Actually, the time that those occur actually will migrate a little bit as the Earth precesses, and that's what they call the precession of they call it precession of the equinoxes, but equinoxes and solstices. But that was a phrase that they kept using, precession of the equinoxes. Okay, so I do have a homework for you. It's not too bad. They're all short answers at the end of one chapter. So it's page 448 is where the first one is found, and then 449 are the last three. Short answer questions. They aren't problems. They're just questions. Questions 4, 23, 30, and 32. Like bingo. Okay? That's a good place to stop.